Problem number 7-8. Find the eigenvalues and eigenvectors of the given matrix A, where matrix A is given as 3, 0, 0, 3, and we have 4 options. In every options, we have lambda 1 and lambda 2 value and both the eigenvalues. Now we have matrix A. Now we can find characteristics equation which is A minus lambda I is equal to 0. Now our matrix will be 3 minus lambda is 0, 0, and 3 minus lambda, which will be equal to 0. We will expand our determinant. It will be 3 minus lambda whole square is equal to 0. So finally lambda will be 3 and 3. So again, like in previous problem, one eigenvalue is repeated 2 times, which is 3 and 3, corresponding to lambda is equal to 3. We will try to find eigenvector. Corresponding to lambda equals 3, we will try to find eigenvectors. Let us consider a minus 3i into x is equal to 0, where this is our lambda, or we can write a minus lambda I into x is equal to 0. This will give our eigenvector. Matrix will be 0, 0, 0, and 0, and we have variables as x1, x2, which will be equal to 0 and 0. Now we got a null matrix. This is a null matrix, so rank of null matrix will be 0, and here in this problem, number of variables which is x1 and x2 is equal to 2. Finally nullity or free variable is equal to 2 minus 0, which is equal to 2. Now we do not have any equation, as our matrix is null matrix, so we do not have any equation. Let's take x1 is equal to k and x2 is equal to t. Now our variables is x1 and x2, which will be equal to k and t. Separating variables, k will be 1, 0, plus t 0 and 1. Now eigenvectors are, we have 2 eigenvectors. First one is 1, 0, and second one is 0, 1. We have created we have created eigenvectors using free variables with the help of k t. we got our eigenvectors. So in this problem we have two free variables which is t and k. So we got two independent eigenvectors in the previous problem. In the previous problem we had free variables as only one. That's why we got only one eigenvector. In this problem of 2 cross 2 matrix, we have our matrix as 3 0 0 and 3, and we have eigenvalues as 3 and 3, and we have x1 and x2 eigenvectors as 1 0 and 0 1.